I misspoke in my previous video on arginine, and I thought it'd be good just to go over peptide bonds and just how amino acids bond to each other. So what you're seeing here are two alanine amino acids. I drew them ionized just in cellular pH of 7.4-ish. The nitrogen will have a positive charge and the carbonyl will have a negative charge. And I don't know if that is necessary to attract them to each other. There should be an enzyme or a ribosome bonding them together. But it is a dehydration reaction, so this oxygen here is going to be separated from the amino acids, and this nitrogen here will form a bond with that carbon. So I think it probably loses its charge once it forms that bond there. I'm not sure about that, but you can see that there's we've connected the two amino acids and removed a water molecule. Let me just bring them a little closer to each other. So what I misspoke and said that the protein backbone was just alternating nitrogen, carbon, nitrogen, carbon. But you can see that's impossible because you need a carbon that has the side chain on it. So it's going to be nitrogen, carbon, carbon, nitrogen, carbon, carbon. Here's the N terminus and the C terminus of the protein. This is not a protein, it's probably just a maybe not even a polypeptide, it's just a very short fragment of amino acids. So there's a few functional groups involved in the amino acids. The carbonyl group is the one side of the amino acid, and the amine group is the other side. And then when they bond, looking at a protein chain, you can see that there's this amide group in the middle of the protein chain. So this would be a carbon with a side chain, and then you have this, and then this would be a carbon with a different side chain. You can kind of see that here. Carbonyl group with the, well, I guess I should call them amide group rather than separate them. So you have this amide group here, carbon with the side chain, and then if there's a full protein, amide group, carbon with the side chain, and just repeating down the protein. And you can see that here on the Wikipedia page for protein. They've colored it green, green, and blue, so you can see there's the alpha carbon with the side chain, and then the amide functional group, followed by alpha carbon for the next amino acid and the side chain of the next amino acid just down the line. And those bonds are called peptide bonds. They're a dehydration reaction because the water molecule is released. You can see here the amide group in the middle of the chain, with the R being the side chain on each amino acid.